In computer programming jargon, a Heisenbug is a software bug that seems to disappear or alter its behavior when one attempts to study it. The term is a pun on the name of Werner Heisenberg, the physicist who first asserted the observer effect of quantum mechanics, which states that the act of observing a system inevitably alters its state. In electronics, the traditional term is probe effect, where attaching a test probe to a device changes its behavior. Similar terms, such as bohrbug, mandelbug, and schrödinbug have been occasionally proposed for other kinds of unusual software bugs, sometimes in jest. However, unlike Heisenbug, they are not widely known or used. Examples: Heisenbugs occur because common attempts to debug a program, such as inserting output statements or running it in a debugger, usually modify the code, change the memory addresses of variables and the timing of his execution. One common example of a Heisenbug is a bug that appears when the program is compiled with an optimizing compiler, but not when the same program is compiled without optimization. While debugging, values that an optimized program would normally keep in registers are often pushed to main memory. This may affect, for instance, the result of floating point comparisons, since the value in memory may have smaller range and accuracy than the value in the register. Similarly, Heisenbugs may be caused by side effects in test expressions used in runtime assertions in languages such as C and C++, where the test expression is not evaluated when assertions are turned off in production code using the debug macro. Other common causes of Heisenbugs are using the value of a non-initialized variable, or following an invalid pointer. Debuggers also commonly provide watches or other user interfaces that cause additional source code to be executed stealthily, which can, in turn, change the state of the program. Time can also be a factor in Heisenbugs, particularly with multi-threaded applications. Executing a program under control of a debugger can change the execution timing of the program as compared to normal execution. Time-sensitive bugs such as race conditions may not occur when the program is slowed down by single-stepping source lines in the debugger. This is particularly true when the behavior involves interaction with an entity not under the control of a debugger, such as when debugging network packet processing between two machines and only one is under debugger control. Heisenbugs can be viewed as instances of the observer effect in information technology. Frustrated programmers may humorously blame a Heisenbug on the phase of the moon, or may explain it away as a soft error due to alpha particles or cosmic rays affecting the hardware. Related terms: a bohrbug, by opposition, is a good, solid bug. Like the deterministic Bohr atom model, they do not change their behavior and are relatively easily detected. A mandelbug is a bug whose causes are so complex it defies repair, or makes its behavior appear chaotic or even non-deterministic. A schrödinbug is a bug that manifests itself in running software after a programmer notices that the code should never have worked in the first place. A heisenbug is a bug with catastrophic behavior. History of the term: the term was used in 1985 by Jim Gray, in a paper about software failures, and also in 1986 by Jonathan Clark and Zahai Stewart on the mailing list CompRisks. Bruce Lindsay, a researcher at IBM, found in a 2004 ACMQ interview that he was present when the Heisenbug was originally defined. An earlier appearance in ACM publications is from 1983. Resolution: Heisenbugs are usually resolved through very careful debugging. This works best if one is able to identify the approximate point in code where the bug is occurring. From there, solutions may be sought from inspection of nearby statements or analysis of process dumps. Another technique is to examine logs, especially those produced by lint and lint-like tools. For highly persistent Heisenbugs, it may be necessary to analyze the entire program as a non-deterministic finite automaton to determine their cause. See also: cargo cult programming, chess a tool for detecting and reproducing Heisenbugs, memory debugger, Jinx a tool that automatically explores executions likely to expose Heisenbugs. References. External links: The Heisenberg Debugging Technology, A Story About Magic.